Hey everyone, and welcome back to the channel. Today we have another medium Leetcode question, number 945, minimum increment to make array unique. The problem statement goes as follows. Given an array of integers a move consists of choosing any a sub I and incrementing by 1. Basically what we want to return is the least number of moves to make every value of a unique. So we can take a look at this first example case to see what that would exactly look like. So given an input array of 1, 2, 2, we're expecting to output 1 because we can basically increment this last element by 1 to end up with a unique array 1, 2, 3. So feel free to pause the video right now and brainstorm any potential solutions here. I'll be pulling up whiteboard to better visualize the problem. And we can just take our first example case 1, 2, 2. So obviously, right, at the high level, what we really care about are the duplicates or collisions within the array. In this case, this 2, 2. When we come across collision, we basically just want to keep incrementing that element and also our number of moves until we come across a unique element or a non-collision. So what that would kind of look like is we can sort of create some sort of hash structure or dictionary to keep track of scene nodes. We'll iterate through our array once. For each one, we'll check if it's inside the scene map. Obviously, at this 1, it's not because it's empty. So we'll just add 1, set that to true because we've seen it. Continue our iteration at 2. We haven't seen 2, so we can add that. And then when we get to this 2, 2 is actually already in the scene map, so that's when we know this is collision, and we can keep incrementing this number and increment number of moves until it's not seen in the map. So we would get 3, and num moves would be 1, and we would just return 1. So I think this solution would work with, especially with a small number of inputs, right? I think the problem we will run into is if we're giving a very large array with a bunch of 1s. If we're given like 1, 1, 1, 1, for let's say like 10,000 times, we basically have a collision at every single step. And worst case is that we're gonna have to increment or basically do that increment step n times and name the number of elements in the array. So probably not the most efficient. That would definitely really hurt us in time complexity for our current solution. So let's see if we can find a way to optimize this. I think the obvious optimization method or step is when we start incrementing from 2 to 3, right? Because we don't want to increment each step of the way. I think instead, let's say we have 2 and our next unique element is 10,000. Instead of incrementing 2, 3, 4, 5 all the way to 10,000 and doing 10,000 minus 2 steps, what we can just do is a simple mathematical operation, take 10,000 minus 2, and that will basically tell us the number of moves it will take to reach a unique element. So what would that actually look like? Going on with this same example, 1, 2, 2, we're going to keep track of 2 data structures. The first one is going to be a count of all the elements in the array. So what that would look like is basically 1, 1, because we have 1, 1, and then we have 2 2s. So we'll initialize that. At the same time, we'll also initialize an empty array, which will basically hold all our duplicate values. So as we iterate, we see this 1. If our value in the array is 1, we don't worry about it because we know that's unique. We can continue on. Once I get to this 2, though, I see that this value is 2. So at any point this value is greater than 1, I know there's a collision, and I can append 2 to this duplicates array. So after that step, we would have 2 in a duplicate array. Now, for example, if we had 3 2s, we would want to append 2 twice because we can have one unique element 2, and then basically we need to update these 2 elements to unique values. So let's see how this would actually look like if we pseudocode it out. Create a counter map. Basically iterate through A, for each iteration, if the map at A is greater than 1, we want to append our map at A to duplicates, right? And basically, right, we'll keep going. If it's 1, we don't care about it because it's unique. But if it's actually equal to 0, or if not map A, so it wouldn't even exist, I think this represents a special use case in which we have an empty index or element that we could potentially set our duplicate or a last duplicate to. So what that would actually look like, right? And for this previous example, I'll just put it up. With 2 as 2, we get here, our duplicate array is 2. All right, we're iterating from 0 to the length of the array times 2, which will give us plenty of room for duplicates. So in this case, it would be from 0 to 5. Basically, at our third iteration, or fourth iteration, with x equals 3, we see that x is not present in the array, which means 3 is our very next unique element that's available. So we can just take this minus 2 and basically add that to our number of moves. So if not map A, num moves plus equals x, which is going to be that iteration step, minus map A. Cool. And I think at the very end, we should just be able to return num moves. So why don't we go ahead and code this out. So we'll initialize num moves to 0. We'll initialize duplicates to an empty array. And also we'll have this counter hash, counter map, and that's just going to be equal to collections.counter A, which will give us kind of that format we want. Just to make sure we're on the right track, why don't we just go ahead and print out counter map. We see you get that 2, 1, looks good. So now we can iterate for x in range, and we'll go from our length of A times 2 to account for any potential duplicates. And so if our counter map is at x is equal to 0, is equal to greater than 1. This is basically when we know we have that collision. What we can do is actually append. So we'll say duplicates extend x times our counter map at x minus 1. Right, so if we have that 2 here, our count of 2 is 2. If 3, so we want to append 2 to our duplicates array once. Cool. Else if not counter map x, so basically x is not present in the array, and we have some sort of duplicates. This is when we want to pop out, so our last duplicate, I'll say last duplicate, and we can just pop out the last element in the array. Cool. And basically our num moves will just be plus equal our x value minus last duplicate. Very end of this iteration, we should just be able to return num moves and have our answer. So why don't we go ahead and try running this? Oh, sorry, counter map. Cool, looks like that was accepted. Let's go ahead and submit it. And there you go. Thanks for watching, and if this was any help to you, please like and subscribe. It really helps with the channel. Thank you so much, and stay tuned for more videos.